All right, so now we're going to continue graphing the equation for cosine of 1/3 x. And so we are going to apply the amplitude change and the period change. We'll do period change first, but before we do either of those things, we have to draw our original function. And one thing I'm going to keep in mind is that I know that my period of my graph is going to get actually stretched out, so it fits between 0 and 6 pi. So I'm going to draw my axis so it already goes all the way out to, 6 pi. So we'll put 6 pi right there on the end, and then we'll have 3 pi will be in the middle, 1 pi, 2 pi, 4 pi, 5 pi. Okay, and then I also need the pieces from my original graph that I would use. So if I was going to sketch my original one, you need to draw your important x coordinates for your original cosine function. So that would be pi over 2 and 3 pi over 2. And then I also know I'm going to need, it looks like 9 pi over 2, which I know would fit right here. So, and you don't have to know that part of it, but because I'll always provide it for you. So make sure that you have all of these labeled on your x-axis. Okay, so I'm going to draw my original first. So my original cosine graph starts up at 1 and goes down to -1. And it starts up high at pi over 2, it goes through 0. Then at pi, it's down at -1. 3 pi over 2, it's at 0. And at 2 pi, it's up high again. So we have, there you go. So that's my original. So original. Okay. And then I'm going to do my period change. So I'm taking each of these points that I have at 0, pi over 2, pi, 3 pi over 2, and 2 pi, right? These 5 points, and I'm moving them so they go to their new location. So 0 stays at 0, so I'll still have a point there. My point that was at pi over 2 is going to get scoot on over until it's at 3 pi over 2. So this point is going to go right here instead. So I'm taking, whoops, I'm taking this point and I'm moving it here. Okay. My point that was at pi is going to go to 3 pi, so this is going to stretch all the way over here, right? My point that was at pi is going over to 3 pi. I'm not changing the height at all, I'm just stretching the period of it. My point that was at 3 pi over 2 originally, sorry I covered it up, there is a black dot underneath there. This was at 3 pi over 2, it's going to scoot over until it's at 9 pi over 2. So the dot that was underneath this red one is going to go to 9 pi over 2. And then my point that was at 2 pi, it's going to go all the way over to 6 pi. And so this is the period change of my cosine graph. So it has the same shape generally, it's just been stretched out. It started high, went through my middle, went low, went through the middle, and ended high again. So this is the period change. Whoops. I'm going to write it somewhere out of the way, hopefully. So period change. Then I'm going to apply my amplitude change as well. So I'm going to, instead of my graph only going up to 1 and down to -1, it's going to get stretched up. So it goes up to 4 and down to -4. Instead, my middles stay where they are. So I'm not really worried about changing these dots at all. Those are going to stay right where they are because you can think of it as multiplying by 4, but 0 times multiplying your y value by 4, and so my y value here is 0. 0 times 4 is still 0, so those won't change at all. It's just my two highest points and my lowest point will get stretched to 4 and -4. So 1, 2, 3, 4. 1, 2, 3, 4. So -4, 4. All right, let's stretch it. So this point will come up here, middle stays there, my lowest point goes down here, my middle stays there, and my highest point comes up to 4. So this will be my amplitude change. Oh no, I tried to write the period change out of the way. Scoot around it. There we go. So then that would be my final graph because that's when I have applied my period change and my amplitude change all at the same time. Very good. All right, I think we have one more example before we move on to new types of transformations, and we're going to be talking about those later in a different video. So we're just going to do this one more example. The only thing that's different that we're going to kind of incorporate into this one is this negative. So we'll deal with that at the very end. First, we're going to just follow the same sort of pattern. So I have a sine function, and it looks like I'm going to be doing an amplitude change and a period change. So my 2 here, and remember this is where the absolute value comes into play, right? Even though this is a negative 2 that's multiplying my sine, the amplitude is just how far away your highest or lowest point is from the midline, and so you wouldn't say it's -2 away, you would just say it's 2 away, okay? So my amplitude's 2, and then my period change is going to take my normal period, 2 pi, and divide it by whatever number's inside of your sine function that's multiplying your x. So 2 pi divided by 1/2, it looks like I have a fraction inside of a fraction, so I'm going to flip and multiply. Dividing by 1/2 is the same thing as multiplying by 2 over 1. And so then I'll end up with 4 pi. So this is another scenario where my amplitude of my, let's see, I had a sine function originally. And then I'll talk about what my period change does. So my amplitude is still going to stretch it, so it goes up and down farther. Instead of up to 1 and down to -1, it'll go up to 2 and down to -2. And then this is another example is where my period change is going to actually end up with a stretched out version of my sine graph, because instead of one wavelength fitting between 0 and 2 pi, one wavelength will fit between 0 and 4 pi. So it's going to get, whoa, it's the same height. It's going to get stretched out, so it's longer. So we'll have to take that into consideration when we draw our axes, okay? And again, when I'm doing my period change here, instead of dividing all of these things by 1/2, because that will be a lot of flipping and multiplying, I can make a little note to myself and say that dividing by 1/2 is the same thing as multiplying by 2. Similarly to what we did in our last example, right? I had to divide all of these pieces by 1/3, but that's the same thing as multiplying by 3. So I just made myself a little note before I went through and did this. I'm going to do that here as well. So instead of doing 0 divided by 1/2, I'll do 0 times 2, which still gives me 0. I'll do pi over 2 times 2, and in that scenario, your 2's cancel out. I think, yep. I just want to make sure I'm using the same colors. 2's cancel. When I do pi times 2, that gives me 2 pi. 3 pi times 2, or 3 pi over 2 times 2, my 2's will cancel out there as well, so I'll end up with just 3 pi. And then when I do 2 pi times 2, I end up with 4 pi. Great way to check that you've done it right is if your piece down here matches your piece up here. All right, so now we're going to go ahead and we're going to apply our period change first. So we have to take into consideration that our graph is going to be stretched out from 0 to 4 pi. So when I draw this, I'm going to go all the way to 4 pi. And then 2 pi will be right here. 1 pi, 3 pi. And then I need to make sure I have my first 5 x coordinates that are important to my original graph, my original sine function. So I need to stick a pi over 2 in there and a 3 pi over 2. And then I think I have the rest of these already labeled. 0, pi, 2 pi, 3 pi, 4 pi. Yep, we're good there. Okay, so now we're going to go ahead and draw our original function. There's 1, here's -1. So I'm going to start with my original sine graph, which starts at the origin, goes up, comes down, goes down, comes up, so it makes a wave. And this is the original. And then it looks like I am going to do my period change. So I'm going to take all of these points at their original x coordinates and I'm going to move them so they go to their new x coordinates. 0 stays at 0. My point that was at pi over 2 scoots on over to pi. So this point went here. My point that was at pi goes to 2 pi, 2 pi instead. So this point went here. My point that was at 3 pi over 2 goes to 3 pi instead. Again, not changing the height at all, just stretching the period, just stretching the wavelength. and then my point that was at 2 pi, it's hidden now because I put my moved point on top of it. There was a black dot there originally. It's going to come all the way over here to 4 pi. So that little point that was underneath there will come over to 4 pi. And so I've stretched out the period of my sine graph. Same shape, just been stretched out. So that would be the period change. Now I'm going to change my amplitude. So I'm going to, instead of my highest and lowest being at 1 and -1, my highest and lowest will be at 2 and -2. My middle points will stay exactly where they are because they're at the midline. So even if I multiply their y values by 2, their y values are all currently 0. So 0 times 2, still 0. We got -2, oops, +2 up there. Okay, so my highest point will stretch up to 2. Instead of going up to 1, it goes up to 2. My lowest point, instead of going up to, or down to -1, it goes down to -2. And then we have stretched our amplitude. And this time I'm actually just going to write amplitude change on it because we have to come back and deal with this negative number that was up here. So this is the amplitude change. And now we're going to just barely introduce as to what a negative number does up front. And a negative number reflects your graph over the x-axis. In transformations, having a negative outside of your function, right? It's not inside of my sine function. Outside is a vertical flip or a vertical reflection, which means you reflect it over your x-axis. If I reflect any of these points, so if I reflect 0 over 0, these are all going to stay here, but what's going to end up changing is that my point that was originally high on my graph, I'm going to take it, I'm going to reflect it so it goes down here instead. Oh, I don't like the use of that color. It's too close to everything else. Let's do green instead. Ew, pink. So my middle points stay exactly where they are because even if I reflect them, they're still going to be at 0. My highest point is going to flip down instead because it's reflecting over your x-axis. So now it'll be down here. And then my lowest point, which is being reflected over your x-axis, is going to flip and come up here instead. So that'll be up here. So then I have achieved my, I'm going to go right through these other notes. This is going to be my final graph because I have taken into consideration my reflection as well as my last step. Awesome. All right, we're going to get into more detail with reflections, and then we're also going to be looking at vertical shifts next. So go ahead and work on a practice I assign you as of right now, and we will work with this some more together. Thanks, guys.